It's my honor to introduce our first guest, Jeffrey DeCoux. He's the chairman of the Autonomy Institute, and they are forging a path to commerce for autonomy. The Autonomy Institute is working to provide reference architectures and blueprints for the development of autonomous infrastructure labs, mobility corridors, and full autonomous city deployments. This will stimulate mutual testing and developments in regions to accelerate autonomous systems deployment at the edge. This is our second conversation of 3 meant to cover this topic with our global membership. Today, we are tailoring our message and our discussion to see how it can apply to the APAC region. So thank you for joining me again, Jeff.
Great to be here. And it's an honor to take the time to connect with your audience.
Excellent. And I think you're in Texas, yes?
Austin, Texas.
Austin, Texas. All right. Everything's bigger in Texas. There you go.
Yeah, everything's bigger. But I would say that we know a lot about the Singapore and the Asian region. And I'd say that we have a lot of catch up to do in the United States.
Yeah, it's always been that quite a bit of innovation comes out of APAC. And I saw that directly as I went over to Japan and different places like, wow, they have this before we do. So there's definitely collaboration. But, first off, thanks again for joining me on this second segment. And we've all been talking about the edge, and everyone seems to have their own definition of it. We talked about this in the America Summit as well. So I'd like to hear about what the Autonomy Institute's vision is. First off, so what is the Autonomy Institute and why was it created?
Yeah, it's a long story that I'll make short. I mean, I say that for about 10 years, we realized that connected and autonomous systems were going to be a transformational to many industries and to many impacts to society. But we also realized that there was going to be a shift to how that was going to be enabled. So what happened is a lot of developments occurred over the last, I say about probably 7 years. And then about 3 years ago, we realized that the edge was going to be vital to how intelligent and autonomous systems were going to be deployed. And that led to the formation of the Autonomy Institute, which is a 501c3 focused on a path to commerce. It's not focused on new standards. We believe that there's plenty of standards, plenty of technologies on the shelf that need to be deployed. But how do we prove out and get these systems starting to support the cities that we live in and to really accelerate and meet community needs?
Yeah, and this is, for those that don't know the Autonomy Institute, I believe you've got over 80 companies participating in this now. Is that right?
I think we crossed over 100, I think earlier this week. Yeah, so there's a lot of interest, and it's mainly, autonomy has been pursued for decades. Obviously, it's been extremely successful in the space race on what can be done autonomously. But really, from the grand challenge that DARPA set out in 2005 has really led to a lot more interest on how this can be done.
Yeah, accelerating that innovation again with challenges out there to get those creative minds trying to solve a problem, which is really cool.
Exactly.
So you know me, I'm a visual guy. I'd like to use a graphic to help everyone understand the solution that you have been standardizing on. This is called a Public Infrastructure Network Node, or as we like to call it, a PIN. This is a little busy slide, but the basics of it are pretty cool. So can you just walk us through the design, why this, and what elements make up the PIN?
Once again, it's a long course that led us to this. So the Autonomy Institute, once again, its established goal was to get connected and autonomous systems deployed within regions. But what happened in 2018, late 2018, early 2019, when we were meeting with cities, we heard a clear issue that they were facing of the number of permits and the number of requirements for new types of technologies to be deployed in a city, whether it be 5G, which we've all come to see as a critical deployment, but IoT devices, intelligent transportation devices, assured position, navigation, and timing. And that led us to look for what is the solution. But what we found is even the smart poles that were out there were really focused on proprietary solutions and primarily around lights. So what that led to is several dozen industry partners coming together and developing what is called the PIN, the Public Infrastructure Network node. The best way that I've heard partners describe it is if you were to take a 19-inch rack out of a data center and drop it on the sidewalk, what would it look like? So it certainly does not look like a 19-inch rack. Let me assure you of that. But what it does have similarities to is how it's modular and how it's designed to accommodate technologies for today, tomorrow, and well into the future. And it's now becoming a new asset class to a city.
Yeah, that's an important element I want to talk about in the next question. But let's just go through the details here. And just again, to break it down, the base here is all full of compute, right?
Exactly. So, I mean, I think a lot of people have seen a reason to have 5G processing at the edge to take the baseband and turn it into proper network traffic. But there's so many more needs for processing at the edge or compute at the edge. And we quickly realized that the requirements were well in excess of just a couple kilowatts of compute. And that led to the development of how can we put 10 to 20 kilowatts of compute on the sidewalk. Mm-hmm. And we see that actually extending beyond that because of some of the recent use cases that we've seen. But in the base is to start about 10 kilowatts of compute, which includes not just GPU, but GPU, and also advanced FPGA processing. And then in the mast from the base up is the ability to deploy not only wireless networks, which most people think of as being why this technologies or why these devices are deployed in the city, but many, many more sensors, ITS sensors, radar, APNT, assured position, navigation, and timing, which is an enhanced GPS. But even environmental sensors, there's companies like Array of Things that have done very successful deployments of how sensors can give far better insight to cities to better manage and maintain. Mm-hmm. What this picture doesn't show is another incorporation that took place over a year ago, which was the vault, because the need for resilient power of these devices in the case of a disaster or emergency management, where there's going to be 20 to 60 kilowatts of battery reserve in the units.
Yeah, and this is if you notice, it looks kind of like a light pole, and this was designed specifically to blend in to the landscape, correct?
Very much. If you notice that most previous technologies like smart poles were designed where things were attached to the outside of the devices. What's very different about all the standards that have been developed is these sensors are being designed to be inside the pole looking out or projecting signals out, which I think makes it the cities in the states have been very supportive of that type of design because of the aesthetics. It also affords different type of aesthetics outside. So we've seen many different instantiations of what it can look like. Some of the most unique, of course, are in Austin, Texas. We are known to be very unique. And they're looking at some of the pins on the outside appearing to look like a guitar or a cello on the sidewalk, which is a piece of art.
Yep. Yeah, that music scene in Austin specifically, right?
Exactly.
Very cool. So, the basics here are there's compute at the base, and then you've got all these sensors and all these things that go up. But the vaults you were talking about are also going to be just larger things that are subterranean. So dug in, right?
Well, exactly. And it's not going to be just the electric infrastructure and the fiber and the power going to these units. Another thing that the Department of Energy has realized here in the States is that 3 years ago, they did not expect the success that Tesla has had with electrification of mobility. Now that pretty much every single car company is committed to a full transition of the fleets, they're now having to prepare for additional ways to compensate for that energy, and having inverters and additional storage more densely deployed across the city is going to help provide resilience to the grid.
Yeah, so this is fascinating for me because we've all talked about the edge, and I remember the first things of, okay, we got to put cameras out, and we're going to people movement, and then there's going to be compute aspects. And what happened is that in these intersections within these cities, all of a sudden you're going to have 5 or 6 different boxes out there for all these different services that are needed. And so what this is solving is standardization when it comes down to they all need compute, they all need some kind of GPU, they need some kind of FPGA accelerator, some type of thing. But if you can offer that standardized shared platform of compute, all of a sudden lots of different capabilities can pop up. And then you just keep distributing these same standard units all over the city.
Not maybe everyone on the call will remember, but there was a time in the early 90s that people thought it was not possible to have a lot of data centers. That everybody thought it was going to be a couple centralized data centers across the U.S. And now we're, I think, in excess of 3 million data centers in the U.S. alone. I think the same thing is occurring here. I think edge has a lot of meanings. To us, we need to have sensors processing really robust data that's valuable to a lot of different use cases on the sidewalk. But edge also includes those micro data centers that are at the base of cell towers, which are going to be vital to, in a lot of cases, data sovereignty within a city.
Yeah, and there's much more to unpack in that, and I'm going to ask a few other questions around that too. But there are 7 million data centers globally.
7
million. So if you think about that, yeah. And this is all types. And the calculation we've done is there's 35,000 megawatts of capacity built today. That's going to be scaling in tens of thousands of megawatts over the next 3 to 5 years. And that's just in core. So now you think about edge, it's going to accelerate very quickly. So I'll tell you what, this looks awesome, by the way. I love the design and the standardization of it. But I want to talk specifically about how it's funded, because a lot of people say, great, edge, where's the money coming from? And so specifically, you have a thing that you approach right now called 3P, public-private partnerships, right? So
exactly.
What are they and why are they important to this initiative?
Well, I'd say 4 years ago, we didn't necessarily, I understood P3s. I understood P3s from the standpoint of tollways and bridges and dams. I did not understand how a P3 could be really fit into this model. What happened is we were trying to solve the technical challenge of how can we allow a city to better manage, maintain, and operate all the tsunami of sensors coming into the city. That was successfully solved with a PIN. What that also did is when many of the large private infrastructure investors saw the PIN, they got extremely excited because that was the answer for them on how they could invest in the edge. Because as you know, infrastructure investors, they can pay for data centers. They can't pay for the computers in the data center.
Right.
They can pay for a massive deployment of fiber, but not the networking gear on the fiber. Mm-hmm. And up until the PIN, all devices, whether it be IoT devices or small cell or 5G devices, were all being attached, strapped, or bolted to current infrastructure that already existed. There's no economics that they could play into. What happened is when they saw the PIN, they quickly got excited and helped educate us that the public-private financing, there's tens of billions of dollars that will underwrite the deployment of PINs within a city, down highways, down interstate corridors, to really support from the end game for us is intelligent and autonomous systems, but really for the next few years, this densification of infrastructure is really going to eliminate things like the digital divide within the US. It's going to just make it just completely evaporate. A lot of people compare it to the 1936 Rural Electrification Act, which in the US, where every single farmer got power. Everybody got power to the grid. And the same thing's going to happen, but instead of power, it's data.
So, and let's hold that for a second, because I want to weave that into a couple other questions, because the digital divide is so critical. Digital inclusion is something that we've got to have, but there's a unique value proposition here that we didn't really see was going to happen. So I'll hold that for a second, but I do want to talk about how this is going to roll out, because here you've seen the standard design. And so across the US, but let me connect a few dots first with the PIN infrastructure and these smart city initiatives, because there's a lot of buzz going on. So, well, let me share this picture really quick. So we have what we call the PIN, of course, and that is, this 10 to 20 kilowatts. So those things start going out through all over the city. But there's a limited amount of compute that can be within that actual base. And the vaults are not really meant for that. They're going to be for other infrastructure that are going to support the pins. So there's a need for this. And think of this as that down to the last 1,000 feet or last 300 meters. This thing is serving the stuff all around it. Okay, whether it's businesses or people with their devices or machines or sensors or other things, they're all going to start to go through these type of local compute things. But there's going to be need to be a little more horsepower that supports that. So the second block is of micro data centers. So think of these as the modular ones that we've talked about for years, and many players are in this space. You start to throw out like anywhere from a 3-rack type config to a 40-foot container landed somewhere, right, in a parking lot or in other real estate, but it's going to have similar things. There's going to be more compute, more storage, more things to serve that local metro. Then on top of that, you're also going to have metro data centers. So this just keeps getting bigger and bigger. And what's important in this, from my perspective, is that these are all part of an ecosystem. And that ecosystem is compute, right, and storage capacity and acceleration capacity from a GPU and an FPGA standpoint that is accessible to people in that metro. But what this allows it to do is all this stuff is shared, and you now create networks of networks on top of it. So we can have a healthcare network, a transportation network, all these things that allow all these different entities to leverage it. And what you said was really important, that asset class now for data centers, like you said, they can't invest in the compute or the sensors themselves, but they can invest in the pins and the infrastructure underneath it to make it work, the vaults, the fiber, the elements to do that. So that's, when you look at the public-private partnership, this is where the money starts rolling in. And how much money are we talking about here that is around that asset class and investment?
Well, it's in the tens of billions, and we were asked last year by individuals in Washington that basically said, what is the size and scope of this? And what we decided to do is break it down like the interstate highways did, is break it down to the highways that ran north to south and then west to east, and included the cities, basically the top 300 cities on down. And what that came to about 101 billion for the core of the pins that were being deployed. But once you start looking at some of the more advanced services, it'll even be more dense. But right now, that was for the cities, for the highways, and the interstates between the exchange.
And this is pre-approved money. It's already there. This is transportation dollars, right?
Well, there's transportation dollars. I'd say that. So when I'm talking about dollars, I'm primarily talking about the private side. But I will say that currently in the U.S., there's discussion of a several $1 trillion spending package. 381 billion of that is directly attributed to how this infrastructure can basically transition the United States into the 21st century, whether it be simple things like broadband, accelerating 5G, and really giving us that intelligent connected system for transportation.
Yeah, this is so exciting to me, because it all comes down to, you got these great ideas and shiny new things, but who's going to fund it? And so there's real money rolling in from multiple sources that are going to be complementary in rolling it out and solving problems. And the smart city initiatives and the mayors and everybody else that are going at it, this is a value prop that is resonating from what I'm hearing.
Across the board. I mean, there hasn't been a single conversation. Once it's quite interesting. We did not set off to establish a new standard of PIN at the Autonomy Institute with all the partners. But once that is described to a city, to a state, or to any federal agency, the first question they ask is, why are we not already doing this? And so... And I think in the States, I mean, I know that Asia far more advanced on more advanced infrastructure, but in the U.S. we have not had a large infrastructure build out since the 1960s. So majority of the generations that are actually in pushing technology have never experienced something at this scale before.
Yeah, and the thing is that there are parts of APAC that actually are very advanced, and there's others that are challenged, and we're going to hear about that in the panel itself, right? Because rolling out infrastructure in India is very different than rolling it out in Singapore.
Yeah.
Right. Same thing with Australia with its size to what happens in China. So it's very different in that, and there's such a huge combination of different countries and challenges in each. But I'd like to talk a little bit about the first rollout. So in Texas that you've got, I think it's a Camp Mabry. Is that correct?
That is.
Okay, and let's just tell us a little bit about that. I've got a picture of this this rollout here, and then we're going to apply this back into what it means to an APAC type look.
Oh yeah, that's a little bit older picture. There's now 34 pins that are going to be actually being deployed, so they're shipping down now. And what the Camp Mabry is, it's not a federal DoD base, it's a state. And in fact, the majority of the work that this base does is disaster response to emergencies, not just in Texas, but nationwide. There's over, I think, 25,000 reservists that are involved. What they saw is they saw the leadership role they have. Number one is because public safety is one of the first that's going to see a lot of the benefits of this type of infrastructure, but they wanted to embrace the testing and rapid deployment of the edge compute, the sensors, and start to deploy things like, simple things like autonomous lawnmowers that are actually maintaining, the base.
Wow.
Shuttles that transport people around, and rovers that do various tasks. But it once again starts with very simply a very resilient network. Because even in Austin, we're the high tech capital of Texas, but when it comes to wireless connectivity and speed, we are very much lagging on what is the art of the possible.
I hear you on that one. So let's thanks for the intro on that one. The fact that this is rolling out, this isn't just a concept. This is actually rolling into a city and many other cities.
Yes. Yeah. Right? So this is over 2 years in the process, and there's multiple segments. So Camp Mabry is first, and then we have a collaboration that we see moving forward very quickly with a campus, a university campus. The city of Austin now has over 80 individuals that are really helping, number one, communicate to the communities and support different types of adoption of the technology within the region.
Yeah. And so I want to shift gears a little bit, because you've got Camp Mabry, and then you're going into more opportunities just within Texas. And then, of course, there's another dozen cities outside of that. Everyone's going, I see it. I actually want to do something with it. But after our panel here, we've got our discussion here. We've got a panel of other leaders from the APAC regions, and they're discussing the opportunities and the challenges in their areas of the world. But let me share a few stats around relating to edge, and then I'm going to ask you a relevant question around that. So the market for edge computing in APAC is estimated to grow 21% between 2019 and 2024, reaching $5.8 billion. By then, APAC will become the second largest edge computing market, only trailing North America. So, of course, IoT and 5G will be crucial drivers for that increased adoption, of course, of edge computing offerings within that region. Also, public cloud service providers have been ramping up their edge computing offerings as of late. So, for example, Amazon Web Services recently updated its Snowball Edge product. Microsoft announced its Azure Edge Zones, and Google unveiled its global mobile edge computing strategy. So these offerings are going to be expected to make their way to APAC. And given the growing demand for edge computing in the region, I think there's going to be even more, because those are the big players. But there are other players, such as what's going on with the Autonomy Institute here, where you're going to start to bring in even more. So can you share how the Autonomy Institute model could apply to APAC cities?
100%. So that is a good time to actually clarify, the Autonomy Institute, our whole focus is to be a catalyst anywhere for intelligent and autonomous systems and basic cities. So it's, even though you'll hear us talk a lot about Texas and what's happening in the US, we know clearly it's going to be adopted much faster in countries like Singapore and probably more aggressively in other regions in the region. So our focus is just finding the leading institutions in the other regions and supporting their vision and their leadership on getting that same process in the regions that they represent.
Excellent. Yeah, I could see us sharing information back and forth between it. So this solution can work here. It can work almost anywhere in the world. So this is great. A different question on this, and this applies everywhere. There seems like a lot of disruption in cities to install this infrastructure. I mean, digs. So you've mentioned before to me a dig once approach. I believe this ties to the UN strategy. Can you expand on that a little bit?
Yeah, the UN as well as the World Economic Forum. There's several that have done a lot of research on the dig once, put down smart infrastructure, meaning like put down, if you're going to dig, take the time to put additional conduit and additional capabilities in the ground. Here in the States, we have Granholm, which was the DOE supporting that same cause. The goal is that you dig once and really consider what's going to be needed today, what's going to be needed 10 years from now, and at minimum 20 years in the future.
Right.
And that will help. I mean, preferably you want to think about 50 years because of the way, especially some cities grow. So some cities might be projected out 20 years, but others will be projected out 50 years. Like the city of Austin, as an example, would be one.
Wow. So, and the point is that you don't want to be digging on one side of the street for something and then digging on the other side of the street for something else that ultimately are serving similar things. So, right.
Yeah. And this, it really solves the biggest challenge that CFOs of the carriers and the ITS vendors and the edge compute vendors have is if right now everybody's trying to get out there for their specific use case, and that means their own permit, their own construction process. And what cities really has happened about 2 years ago, they finally were hit with so many requests that they finally had to say, time out, we've got to find a way to better manage this. And I think the appetite in the US is we need to accelerate and adopt technology very quickly. But now we've realized we have got to do it in a much smarter way and solve for it.
We got to orchestrate between the different entities to do it once.
Yeah. Yeah.
And then leverage it many times after that.
Exactly.
Well, many people, when they talk about edge and smart cities, what comes to mind are all these shiny new things like autonomous vehicles and drones. But we are far away from level 5 autonomy for vehicles in most of the world, right? China seems to be way ahead, but the majority of people it's just a big challenge. So your approach at the Autonomy Institute is more practical. You're building for today's needs. You're preparing to serve future edge cases. And so tell me what those current kind of critical use cases are today. What's driving it in the cities?
Well, I'd say the number one across the entire United States is the digital divide, or better said, broadband. So it's we've had a lot of even in our high-end neighborhoods, we have a digital divide of not having the proper access to connectivity and speed. So if you look at most of the cities, we clearly see that just getting resilient connectivity and enough bandwidth in the regions is the key driver. Then we see mobility being the second driver because of the event of COVID in the last years. The interest in seeing shuttles or rovers deliver groceries to people's homes or food items or transport medical people around the city has skyrocketed, and that requires additional sensors and compute to be deployed across the city.
Got it. So there's broadband, and then I remember you and I talking about there's data exchange, there's digital twin needs, and then public safety, I think, were other use cases. today, correct?
Yeah, the four that we talk about is for sure the digital twin is foundational to everything. The digital twin actually happens even before infrastructure is deployed, and it's utilized in the design of additional sensors, and it's used then operationally. The data exchange is one that we did not see even a couple of years ago, but it's one that countries like Europe have been very much on the forefront of adopting, but it really comes down to data sovereignty. So if you're going to have all these sensors on the sidewalk, the communities really want that sensor data to be utilized locally, but not at a national level. So that's spearheaded. How do you allow these sensors to be deployed, but really protect privacy and protect the personal interests of the communities that they serve? Public safety, I'll tell you, we were just, we did a tour with almost 50 individuals from the city of Austin for the 3 locations that the pins are being deployed. And all 3 locations, the lead use case was public safety and response to whether it be fire or emergency or a car accident and activities like that.
Yeah, which is, again, this happens all the time. You look at Hurricane Sandy and loss of connectivity, right? Loss of cellular as well as loss of power, and everything slowed down and people lost their lives. So being able to have something that could be up, that can service very quickly, like it's just it's a really, really interesting use case because everyone's going to need it. We need it now. Exactly.
And so, that was probably the one of the champion reasons for TMD getting involved is they had in 2017 experienced the multiple wildfires in the United States, multiple hurricanes in the United States, multiple floods in the United States. And when we started talking about the PIN in early 2019, they saw that as a way to have resilient communication during an emergency.
Yeah, and orchestrating that to make sure that critical services are up all the time, even while other services are out. So yeah, it's just distributing out this ability to be able to support what's going on, especially during a disaster.
And have power orchestration.
Yes, yeah, because all this stuff comes down to I got lots of stuff in lots of places. How do I make sure it's orchestrated to be used in the right manner and the right priority? So this is an amazing use of technology, and of course, this is helping to accelerate those smart cities initiatives and to better lives. But you shared just a little bit ago that it has an even broader impact and it's a selling point for cities. And so we talk about digital inclusion as the solution. How do we get everybody included? Can you share a little bit more about that selling point? What you mean by this?
Well, it's quite interesting. When we were going through the pictures, this is just happened. We were comparing the rollout of the first pins to other transformational technologies or infrastructures that have been deployed. The rail, electric, telecommunications. What was quite interesting is in all the pictures, if you go look at Google and what was the first power station, what was the first telecommunications, the first rail, it's all, not to insult myself, it was all white guys. And now what we're seeing, what we saw at the rollout of the discussion of the pins is it was the most diverse group we've ever seen. I mean, there was, women and, multiple, generations as well as multiple cultures all involved. And it was clear that this was the time that a big infrastructure was going to really have everybody involved with it because it affected everybody's lives or really their daily lives, and they could be part of it.
Yeah. This is such an important thing and ties right to the iMasons vision, right? That how do we make sure that everybody's going to be included? And right now, broadband and these projects, jobs and access to the same things that everyone gets, regardless of economic situation. They all should be able to have those means to go back and continue to lift themselves up more. And so, these things will allow that connectivity.
Millions of jobs.
Right. Yeah. This is the stimulus that's needed. And it doesn't matter if it's in the US or across different parts of the world. The whole point is to get people employed, get them opportunities, right? Get them connected so they can participate equally with like anybody else at any other economic level. So What's awesome about this is that almost everyone in this meeting here will be playing a part in this space. So whether you're a builder, you're orchestrating all those pieces, I'm sure there's going to be a lot of questions from people, and I've been seeing them pop in here. I'm going to open that up now. We've got a few questions that have popped up that
Great.
I want to address. Let's start at the top. So the pin looks like a fascinating product. How to power thousands of them up on the sidewalks. So how do you plan for that to work?
Well, luckily, every single power company we've talked to, they get excited about it because it's of course new demand, and they clearly say there's no issue getting power, even if it's 10, 20 kilowatts per pin. The way the networks are built, they'll find a way to get power to it. So it's an opportunity of growth. And
it's this dig once thing again. So whether it's electrical, fiber, water, et cetera, you're going to get these resources over to where it is. And again, if it's planned appropriately, you're already designing to be able to handle this kind of thing.
Well, and to that point, I mean, we're trying to get pins at the intersections, but we also know that there's going to be technology in between the blocks. And that's really where the charging stations have to occur for mobility.
Yeah, exactly. Because then this ties into EVs and everything.
Yep.
Well, we could talk about that for another hour, but somebody asked what the height of the pin is.
We've pretty much adopted the standard. So there's 4 manufacturers that we're working with. They're 34 to 44 feet tall, which are pretty much meet the US specifications for what has been designed.
Got it. And what's your expected distance between the pins, say in metropolitan areas?
Depending on the sensor and the use types, they can be in a downtown congested city. They can be as close to each other as 300 feet. But down highways, they could be seen as over a kilometer apart from each other.
Excellent. Okay, and I always look at this as every street corner, every city block,
every street corner for sure.
Yep. And there's going to be need. Because the local offices, the sensors, the machines, everything else is going to be using this.
Yep.
So another question came in: how do you see space connectivity will change or help the edge industry?
Do they mean like the Starlink?
Yep.
Yeah. So unbelievable. There's a lot of locations down highways that we're going to be able to tap into fiber. But there's a lot of rural communities that don't even have fiber run to them. So we see the pin. In fact, we have several pins that are designed with Starlink downlink in them. So it's Starlink backhaul, front haul, and in standard 4G, 5G to the devices.
It's all going to be connected. All right. Last question, then I'm going to ask you one other one. So what type of private enterprises do you think will be the first movers in the PPPs to build out the PIN infrastructure, broadband internet, infrastructure funds, et cetera?
Well, we see infrastructure funds as being the lead. That's the ones that we're talking to daily. Yeah.
Got it. Awesome. Okay. So, Jeff, again, our time has just blown right by. This is always fascinating for me. So great. Thank you so much for spending the time with us. In closing, just what key points do you think that our members should take away from your presentation?
Well, I think the key point is just the recognition that the PIN can really, help accelerate the adoption of this technology and eliminate the digital divide and really accelerate us into this 21st century. And it's really, it's quite funny. Every time we have a conversation with another federal agency or state and they see the PIN, the light bulb goes off and they're like, why is this not being done? And we just want to see, just like the early days of the internet, we just want to see it happen as fast as possible so as many people as possible can benefit from it.
Yeah, absolutely. So the flywheel's starting. I can't wait to see this thing start to continue to roll.
Edge materializes, right?
Edge materializes. There you go. Well, hey, thanks for your insights, Jeff. Much appreciated. We'll see you on the EMEA Summit.
Thank you for your leadership, Dean. I appreciate it.
Awesome.